Hello and welcome. I'm doing another fun one today, catching up on some of the fun non-competition cases that I have not got around to. This one is from Jean Wolleh's glut of, I think he released like 7 cases in the space of a couple of weeks over the summer. I've played maybe 4 of them. I've had 3 sitting on my list for quite a while. This one is called Fact-Based Recruiting. And I think someone, maybe Julian or someone, told me that it would be right up my street because it's very data table-y, but let's see. All right. Recruiting is important for every company. Here, applicants are evaluated on the basis of hard numbers. In the datasheet is a table with 1,000 applicants and 100 traits. Oh my god, values from 1 to 100 have been assigned for these traits, with 1 being the worst and 100 being the best. Furthermore, there's a column acquaintances in which some acquaintances of the applicant are listed who are also applicants themselves. Okay, so we've got names in both English and German, so I'm just going to put the English names, get rid of the German names, make this a table, which I will give, as usual, my imaginative name of T. And then, do I want to do 100 lookup lambdas? I've never tried that before, but what the heck? This is the time to find out if that would work. So generate table lookup lambdas. Table lookup lambdas. There we go. Not sure how relevant it's going to be, but anyway. As usual, I'll come back to the bonuses later. How many people are best suited for the given trait? Purchasing power, procurement skills, the maximum value here is 100. In total, 13 people have a value of 100. Okay, so then, so I need to TLOOKUP. Oh, I haven't imported my lambdas. That would help. I need to TLOOKUP in key hash all. Column is that. That'll give me the 100 things, and then I want to, how many people are best suited? Okay. Is this a reference? Can I count if on this? No. Maybe I should try to find a way to make it one later, but okay. So then let nums be that, and I want sum minus minus nums equals, oops, nums, not number value, nums equals max of nums. And sure enough, 13 people are jointly most qualified for that. Okay. Level 2. The applicants know each other. Whose acquaintances have the highest mean for the specified trait? What is an easy way to do that? How many acquaintances are we talking about? There are 1,000 people. Where's the highest? Oh, hang on. Highest total or highest mean? Okay. So I guess what I want is to, I got space here, sorry, space down below. No, I don't. Let's move over here. So I want to map the acquaintances, lambda name, names. Then I want to TLOOKUP in T hash all. I want to look up text split names by, names there by semicolon, semicolon and space. And the other dimension is G47, which is independence, and I want to take the average of those. Or I guess to confirm versus the example, I want to take the sum of those. And then just give me the max of that first. 787, which is good. So then I want to XLOOKUP, let's just say 10 to the 6 in here, returning from tname, exact match your next smaller item. Brackets there. That looks good. That escalated fast. Okay, level 3. Not every trait has the same importance for every position. Using the given weights for the trait to form the weighted sum. Which person is best suited? Okay. So I want to TLOOKUP T hash all. My column values are text split of this on a, this way, no, that way, on a semicolon. Sorry, semicolon space. So that should give me, let's just move over a little. Yeah, that gives me a bunch of numbers, which is what I want. And then I want to multiply that by text split of this also that way, sorry, and also with a space. And then I want to by row sum that. And then I want to XLOOKUP 10 to the 6 in that, returning from tname, exact match with smaller item. And that's good. Okay. Overqualifications are also an important issue. You don't always want the person who can do everything best. It has to fit the job. For the given job profile, which person has the least absolute deviation from the given traits? Okay, so it's going to be very similar. So we're going to TLOOKUP to find the thing, then we're going to subtract those numbers, then we're going to take the absolute value of that all the way out to there. We're going to by-row sum that, and then we want to find the smallest, so we're going to XLOOKUP 0, match next larger. Okay, good. Cool. Level 5. Again, it's about finding the best person for the job profile. This time, however, the traits will be adjusted by weights. Okay, fine. I think that's okay. So just copy this down. Break in a second. So hang on, sorry. Closest to job profile, adjust for the values, not every yes. Yes. Also yes. Before that, however, the traits of the applicants are adjusted with the weights. Wait, what? Huh. The traits are adjusted first? Or the deviations are adjusted? It looks like the traits are, all right, fine. So that's not the right answer yet, obviously, but one thing at a time. So I guess what we're saying is we're going to look up the traits. Oh, wait, sorry. What? This time, however, the traits will be adjusted by the weights. Okay, fine. So then I think we're going to do our TLOOKUP. We're going to multiply that by text split this on semicolon space. Then we're going to subtract off the target, and then instead of taking the absolute value, we are going to square it. Then we're going to sum those, and we're going to look for the smallest one. All right, let's just, I just want to make sure that I'm matching the number. So I want the min of those. And that is, yeah, that is the weird number up there. Okay, cool. Seems odd to wait and then get to a target, but it's fine. Level 6, is it? Yeah, just 6 levels. Okay, the last level. As in level 4, traits and the desired value per trait are given. However, there are exclusion criteria. If these are not met, the applicant is automatically out. Of the remaining applicants, which person best fits the job profile? Minimize the absolute deviation sum. Okay. Exclusion criteria. Ability to deal with conflict. Job profile requires someone who has the following values. However, the person must have at least programming greater than. Okay, so they have to have. Okay. Okay, so let's text split this by semicolon. That way. Sorry, semicolon space. Okay. Actually, I probably don't want semicolon. I don't want to split that way. I want to split this way. Okay, so then call it rec be that. Then we'll call it trait will be text before rec greater than less than. I named those the wrong way around, but never mind. And show me trait. Good. Then we're going to TLOOKUP in T hash all, up to semicolons all, on trait. And that gives us a bunch of stuff. Good. So then, I guess what we want is if is number, hang on, sorry, the target for the trait will be the same thing but text after and times 1. So this is going to be text after. So if is number search for less than in trait. Then I want, sorry, these are called vowels, I guess. Then vowels is great. So if there's less than in there, then it's vowels less than. There's not any greater than or equal to, is there? No. Vowels less than terg. Otherwise, vowels greater than terg. So let's just see. We got false, true. Those were 28, 85, 36, 85. So 28 is greater than, sorry, is not greater than 48. So that's good. Ability to deal with conflicts has to be greater than 59. It is good. E-commerce skills has to be less than 45. It is. Wait, what? It should be less than 40. Yeah, that should be true, shouldn't it? And then controlling competencies has to be less than 24. Yes, those are not working. What? Okay, just for a second, vstack terg with all this stuff. And I guess let's also vstack this piece. Oops. So, oh. Is this, I have to put a tilde in front of it maybe to actually find it? No. Right. What? Okay, try find. Is find more literal? No. What the heck? Okay. Just add rec. So what? Find less than in all of these. Okay, that's actually working. So what? I'm so confused. Oh, sorry, because I put in the tilde before I changed it to find. No, that's still. Okay, so we got the requirement, the target, and then is number. Find that in, because you're looking in trait and not in rec. Ugh, stupid. All right, fine. So then you probably didn't need to change that at all. Okay. So now that still says all false, but that's because you're doing the wrong thing. So look in rec and search. Okay, so now we've got two greater thans and two less thans, and that is exactly what we want. Good, fine. All right, so then we just get rid of all that debugging stuff. So these are the checks. Then I want by row, and because these all have to pass. Okay, so then I'll call that filts is by row and blah 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 blah, and then we just need to bring back in all the other stuff. So I got job profile. Yeah, so back to L4. Copy that down here. Arla Fisqual. I'll try to remember that. Okay, so we're actually looking up 0, so let's just do by row abs. That all seems to be fine. Let's just do plus if filts 0, otherwise 10 to the 6. That should force them all to the top. And we get Arla Fisqual. Sure enough, happy days. Well, I don't know if it was Julian or who told me, but I agree that this is right up my street. For which trait are the applicants on average best qualified? So it's going to be XLOOKUP 100 in BICAL. This, actually, yeah, we do BICAL the whole table, sum, returning from T hash headers. Exact match or next smaller item, because the first and last columns that are not numeric will just sum to 0, so they won't be a match anyway. No? What? 100 next smaller item? Oh, sorry. Yeah, average. Because it was snapping back down to the 0. What? The product? Yeah. Really? Really? Make it 101. Does that change things? No. What? Okay, let's just go check. Just go down one more so it catches them all. Okay, so the max is 52.863, and that's somewhere around. Oh, there it is. Yeah, product knowledge. I might just stand by product knowledge then. which last name is the most common. So my only question here is star, 3 star, 3 star. Is there anybody with, no, okay, they're all just space. So that can just be at most of text after T name after space. Cool. If each applicant forms a team with their acquaintances and each team then takes the highest value of the team members for each trait, which person has the strongest team? I assume strongest defined as the sum of all abilities. Okay. So equals map T name and that and T acquaintances. Acquaintances I can spell. Lambda team. And then what do we want to say? We want to say T lookup in T. I want everything except the last column of T, so I'll just say drop T hash all last column. That's what we're looking up in. Who we're looking up is text split of the team by semicolon space into rows, and that's it. So that gives us the 100 columns of traits for whatever number of team members we have, and then we want to take bicol of this and max, and then I assume we want to sum. Then close the lambda, close the map, and then we want to XLOOKUP. So it's 100 traits up to 100, so we can XLOOKUP 10 to the 4 in that. Exact match or next, as our return array is tname, and exact match or next smaller item. Good. Okay. If you use the following instead of the given exclusion criteria in example 6, who's the best for the job? Okay. Where are we here? I think the way I have this set up, it should just fall out. Okay, so what is the intended answer here? Did I stuff something up? Bicol T average, yes. Return from T header is exact match or -1. Yeah, all right. What was it supposed to be? Ah. Product slash product knowledge. Okay. Right, I guess the headers were intended to be combined some way or something. I don't know. Anyway, okay, so I think I'm actually right about that, so that's good. Oh, yeah, it's a typical Jean case. All that work, which I thought went pretty well, and it turns out the case is marked out of 260 points. I don't know what Jean has against 1,000. It's like, no, this was trivial. This should only take you 5 minutes, because then you have to go on and do the rest. Anyway, that was a fun case, and I agree that it was right up my street. Loved it. That's all I got for today. Thanks for watching. See you next time.